Negative b times negative b is positive b squared. I forgot that there. So all you do is you plug in negative b in the proper spots, you carry your signs through it. It's really an exercise in keeping the signs straight. Negative b times negative b is positive b squared. Negative 2 times negative b is positive 2b, and the 3 just carries down. So again, it all hinges back to the first few lessons in the entire course, which all dealt with how do you multiply numbers in algebra. How do you multiply negative numbers and positive numbers and fractions and all those things that kind of seemed like maybe they didn't have that much direct relevance on algebra. In fact, rules almost everything as you go farther along in this stuff. Okay, we'll do something a little more challenging, but basically the same idea. What if I have p of x, this is my function, equals 5x minus 2. That is my function. And then, so I'm going to draw a box around that. I'm going to leave that alone. And what if I want to evaluate p of 1/5, which means x is equal to 1/5? Well, I'm going to have 5 times, and then the x is going to be 1/5 minus 2. 5 times 1 over 5 is simply 1, which, if you want to think of it a different way, this is sort of 5 over 1. This is a fraction, and these 5's cancel out, so this 1 minus 2. 1 minus 2 is negative 1. So that's the answer to that. What if I have p of u squared? So everywhere I have an x, I'm going to put a u squared. That's going to give me 5 times u squared minus 2. And there's nothing much more I can do with that. It's just going to be 5u squared minus 2. Okay. Let's take a couple of additional examples associated with this polynomial. What if I have p of negative 4z to the 6th power? That's going to be 5 times negative 4z to the 6th minus 2, which is simply going to be 5 times 4 is 20, and it's negative times positive, so that's going to be negative 20 z to the 6th. That comes along for the ride here, minus 2. That's the answer to that. What if I had something a little different, like p of x plus h? You handle it the same way all the other things are handled. 5 times x plus h, because this goes in where x is, minus 2. Now how do we handle this? You've got 5 times something in parentheses with an addition. You have to use the distributive property to multiply this 5 in here, and we learned that in a previous lesson. So that's going to be 5 times x is 5x plus 5 times h is 5h minus 2. And that is the answer. So you really have to keep track of your distributive property and come in and save your bacon sometimes. Okay, the final example here in this chapter is going to be, what if I have p of 2y plus p of z? What the heck does this equal? You handle it the same way as everything else. You have a function here, you're plugging in 2y, and a function here, and you're plugging in z. And you're plugging into this function up here. So I'm going to have 5. This is equal to 5 times 2y minus 2. That's this term plugged into the top. Plus, and then I got to do this one. I'm plugging z up into the top here. 5 of z minus 2. Okay? And to kind of keep it straight for you, this part right here is the p of 2y, and this part right here is the p of z. And all this stuff is equal to 5 times 2 is 10y minus 2 plus 5z, there's nothing much I can do with that, minus 2. So this is simply going to be equal to 10y plus 5z, and then negative 2 minus 2 is simply equal to negative 4. So p of 2y plus p of z is equal to this expression at the bottom, 10y plus 5z. That is an introduction to polynomials and what they are. They are basically a shorthand way of plugging in the value into the expression. In the next section and the ones after, we're going to learn how to multiply polynomials, divide polynomials, add and subtract them, and go through a lot of examples with regard to that.